Hello, madam. And hello, friends. I now understand that coordinate geometry is an approach to combine geometry with algebra using coordinates of points. Also, we can find out the distance between 2 points using their coordinates. But what about the other informations like area, perimeter, distance, etc.?
All these and many more can be calculated using coordinates. We take a simple case first. Try to recognize the figure ALMB.
Yes, it is a trapezium.
You are right. Now tell me, how do we find out the area of a trapezium?
Area of a trapezium. Yes, area of a trapezium is equal to half multiplied by sum of their parallel sides, again multiplied by its height.
You are right. Half sum of parallel sides multiplied by height. Now suppose the coordinates of A and B are x1 y1 and x2 y2. Then we can find out its area as half multiplied by sum of the parallel sides, that is y1 plus y2, multiplied by the height, that is x2 minus x1.
Oh, that's good. It means that we can find out the area of trapezium using their coordinates.
Not only trapezium, but other figures too. Consider the triangle ABC with coordinates x1 y1, x2 y2 and x3 y3. Now we want to find out its area using these coordinates. So first of all, we draw perpendiculars AL, BM and CN to the x-axis. Then we get three trapeziums ALMB, BMNC and ALNC. And you know that if we know the coordinates of a trapezium, then we can very easily write out its area.
Now I can follow. Area of triangle ABC can be found out by first adding the first two areas and then subtracting the area of the third trapezium.
You are right. So we find out the area of the first trapezium as half into y1 plus y2 into x2 minus x1. Area of the trapezium BMNC is equal to half into y2 plus y3 multiplied by x3 minus x2, and area of trapezium ALNC is equal to half into y3 plus y1 into x3 minus x1. So now the area of triangle ABC is equal to, as you said, the area of the first two trapezium, that is area of trapezium ALMB plus area of trapezium BMNC minus area of trapezium ALNC, which is equal to half into y1 plus y2 multiplied by x2 minus x1 plus half multiplied by y2 plus y3 multiplied by x3 minus x2 minus half multiplied by y1 plus y3 multiplied by x3 minus x1, which on simplifying gives half into x1 multiplied by y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2.
A good method indeed, but the formula is quite long.
You don't have to bother about that. It's very easy to remember. Only thing is, you remember that the suffixes 1, 2 and 3, they move in a cyclic order, that is 1, 2, 3, then 2, 3, 1 and then 3, 1, 2.
What is a cycle, madam?
I'll tell you that. You find out the area by first multiplying half with, we start with x1, then that is multiplied by y2 minus y3, that means 1, 2, 3. Again you add it to the product of x2 multiplied by y3 minus y1. Again you see the suffixes 2, 3, 1 plus x3 multiplied by y1 minus y2, that is the suffix is 3, 1, 2.
Really interesting. I can reproduce it now. Area of triangle ABC is equal to half multiplied by x1 again multiplied by y2 minus y3 plus x2 multiplied by y3 minus y1 plus x3 multiplied by y1 minus y2.
Now let us take an example. Let us try to find the area of a triangle whose vertices are 2, 4, 0, 1 and 4, 7.
Yes, we have to plot these points on the graph paper.
No, we don't need to plot these points. We only need the coordinates which is already given to us. Let us suppose that x1 y1 represents the points 2, 4, x2 y2 represents the point 0, 1 and x3 y3 represents the point 4, 7. Now using the result that area of a triangle is equal to half into x1 multiplied by y2 minus y3 plus x2 multiplied by y3 minus y1 plus x3 multiplied by y1 minus y2. We substitute the respective values here. So we get the answer, that is the area of the triangle is equal to 0.
Area of a triangle is equal to 0? How can it be?
No need to feel scared. It only means that the 3 points given to us, they are collinear or they lie in a straight line, or it implies that the 3 given points do not enclose any area or they enclose 0 area.
So 0 area tells us that the 3 points are collinear. A very good test for collinearity of 3 points.
Oh yes, not only 0, but sometimes we also get negative results using this area of a triangle.
Area negative? I have never come across a negative area.
It is only a matter of order in which the 3 points are taken. If the 3 points x1 y1, x2 y2 and x3 y3 are taken in a clockwise manner, then we get a positive number for the area. In case the 3 points are taken in an anti-clockwise manner, then we get a negative number as the area.
So we should first plot these points in the clockwise manner.
No, we don't need to plot them. We find out the area and then take its modulus.
Oh yes, taking a modulus. Taking a modulus will get a non-negative answer.
In the study of figures, we sometimes need some more results. For example, coordinates of a particular point. Ravi, can you state what will be the midpoint of a line segment joining the points 2, 7 and 6, 9?
The x-coordinate of the midpoint would be between 2 and 6, while the y-coordinate will be between 7 and 9.
You are right. If x and y are the coordinates of the midpoint, then x is given by 2 plus 6 upon 2, that is equal to 4, and the y coordinate is given by 7 plus 9 upon 2, that is equal to 8. Now remember that a midpoint always divides a line segment into 2 equal parts, that is in the ratio 1:1.
Can we find the coordinates of a point which divides a line segment, say in a ratio L:m?
Oh sure. Suppose consider the line segment AB given by the coordinates x1 y1 and x2 y2. Let P be a point which divides the line segment AB in the ratio L:m. We draw perpendiculars AL, PM and BN to the x-axis and the perpendiculars AR to PM and PS to BN. Now observe the triangles PAR and triangle BPS.
They appear to be similar with corresponding angles equal.
You are right. Now since the two triangles are similar, therefore the corresponding sides will be proportional. That means AR upon PS is equal to AP upon PB. Now AR is equal to x minus x1 and PS is equal to x2 minus x. Therefore, substituting these values, we have x minus x1 upon x2 minus x is equal to L upon m, which on simplifying gives us x equal to Lx2 plus mx1 upon L plus m. On similar lines, we have PR upon Bs is equal to L upon m, which gives us y is equal to Ly2 plus my1 upon L plus m.
Madam, is there any simpler way to remember this result?
Oh yes. Suppose this is the line segment AB with coordinates x1, y1 and x2, y2, and P is a point which divides the line segment in the ratio L is to m. Now, in order to find out the coordinates x, y of this point P, we multiply L with the x coordinate of the farther point, that is Lx2, and add it to the product of m with the x coordinate of the further point, and then this sum is divided by the sum of the ratios L and m. Similarly, for y coordinate, again we multiply L with the y coordinate of the farther point, that is Ly2, plus m is multiplied by the y coordinate of the farther point, that is my1, divided by the sum of the ratios L plus m.
I can state it now. The point P dividing the line segment AB, say in a ratio L is to m, will be stated as follows: x is equal to Lx2 plus mx1 divided by L plus m, and y will be equal to Ly2 plus my1 divided by L plus m.
We use this result to find the centroid of a triangle. Ravi, can you state what is centroid of a triangle?
Yes, madam. Centroid is the point where the medians of a triangle intersect.
Consider a triangle ABC with vertices x1, y1, x2, y2 and x3, y3. Let AD be one of its median. Then, since D is the midpoint of BC, therefore, the coordinates of D will be x2 plus x3 upon 2 and y2 plus y3 upon 2. Now, consider triangle ABC with coordinates x1, y1, x2, y2 and x3, y3. Let AD be one of its medians. Then, since D is the midpoint of BC, therefore, the coordinates of D will be given by x2 plus x3 upon 2 and y2 plus y3 upon 2. Now, let G be a point on this median AD such that it divides the segment AD in the ratio 2:1. Then, by using the ratio formula, we can find out the coordinates of G as x is equal to 2 times x2 plus x3 upon 2 plus 1 times x1 whole divided by the sum of the ratios, that is 2 plus 1, which is equal to 3. This simplifies as x equal to x2 plus x3 plus x1 upon 3. In a similar way, y will be equal to y2 plus y3 plus y1 upon 3. Now, Ravi, tell me what will be the coordinates of a point G dash which divides another median BE of the same triangle ABC in the ratio 2:1.
Madam, it will be in the order of abscissa changed like this: x equal to x3 plus x1 plus x2 divided by 3, and y will be equal to y3 plus y1 plus y2 divided by 3.
You are right. So, we can very well generalize that this point x equal to x3 plus x1 plus x2 upon 3, and y is equal to y3 plus y1 upon y2 upon 3, which can be written as x is equal to x1 plus x2 plus x3 upon 3, and y is equal to y1 plus y2 plus y3 upon 3. And thus we can generalize that the points x and y is common to all the three medians, or all the three medians pass through this point x and y.
I have got it. The centroid of the triangle with vertices x1, y1, x2, y2 and x3, y3 will be written as x is equal to x1 plus x2 plus x3 divided by 3, and y is equal to y1 plus y2 plus y3 divided by 3.
We now take one more example to show the use of ratio formula. The example is, find the ratio in which the x-axis divides the segment joining the points 2, 9 and 10, 6.
Madam, can we find out this way? Let us suppose we take the ratio as L is to M and then find out the values of L and M.
No, in that case we will get two equations and we will have to solve that. Since we know that the y coordinate of the point of intersection is equal to 0, therefore we get only one equation. Now recall that a ratio can be represented in the form of a fraction, so that the ratio k means k is to 1, and our ratio formula modifies as x equal to kx2 plus x1 upon k plus 1, and y is equal to ky2 plus y1 upon k plus 1. Now since we know that y is equal to 0, therefore substituting the values here, we get 0 equal to k y2, which is 6, plus 1 multiplied by y1, that is 9, divided by k plus 1, which on simplifying gives us k is equal to minus 3 upon 2.
Again a negative ratio? Madam, can a point divide a line segment with a negative ratio?
In mathematics, we either have an interpretation or we have a way out for a negative result. In this case, k is equal to minus 3 by 2 means that the point P lies on the extended line segment AB, that is AP is to PB. AP is to PB is 3 is to minus 2. In other words, we say that the point P divides the line segment externally in the ratio 3 is to 2.
Yes, I remember. We did the constructions on dividing a line segment both internally and externally.
That's right. That's all for today. We'll learn more about this in our next lesson.
Thank you, madam.